Well, I was given the option to stand to the side like I usually like to do, and then it was taken immediately away from me. So we'll see how this goes. But yeah, it's a true honor to be here. Scott, Lindsay, I appreciate you guys inviting me to speak. I spent several years at the University of Georgia getting my graduate degree. I'm in Auburn now. I'm kind of split between how much time I've spent in Alabama and UGA. So you can imagine that I'm very confused as a football fan right now. And so my kids are trying to figure out, what colors they're supposed to wear. But happy to be here, honored to be here. In fact, I learned a lot about my current knowledge of prescribed fire from many familiar faces in this room. And I'm sure if I get anything wrong, they'll be happy to let me know what I got wrong at the conclusion of it. So before I really get into the details on dormant versus growing season fire effects on vegetation and how that translates over into habitat quality for deer and turkeys, I really kind of wanted to start out by taking a little bit of a different slant on this about, why burn during the growing season. And these data came from a paper that was published a few years ago where the authors were specifically interested in looking at, what are the number of days in each month throughout the average year that weather conditions are actually conducive to prescribed burning. And of course, that pattern that you see in the figure there follows about what you expect, and it makes it easy to understand why so much burning, goes on during the wintertime. But as a starting point, on an annual basis, we have about 90 days in the burn window. And you can see that I've got that divided up into weekdays and weekends, and that's going to be extremely relevant here in just a second. So if you had to guess from a wildlife perspective, what is the number one time of year where people, or you typically hear practitioners say that we should avoid burning? Turkey nesting season, right? So let's go ahead and put that on there. The bulk of the turkey nesting season, Georgia, Alabama, throughout the Southeast, April, May, and June. So if we take that period out, just to begin with, we're down to about 70 days in the burn window. A lot of practitioners are also avid hunters. So, during the deer season, turkey season, we don't oftentimes like to light our woods on fire. We don't have the time for it, or sometimes there's concerns about, influencing the hunting. So let's go ahead and take those times of the year out too. And these are for Alabama, but there's a lot of overlap in the seasons. The biggest thing is that you get the general gist or the trend of the direction we're going. So we're now down to about 29 days in the burn window. All right. Many of us, there's a lot of professionals in this room, so burning is your job, but there's a lot of landowners too, and many of us can't burn on weekdays. We have other jobs that we're using to pay those property taxes on our land. So if we take out those weekdays, we're now down to about 8 days in the burn window. Who's burning in July and August? On a show of hands, we've got a few of us. I burn during July and August, but there's not a lot of fire, being put out there by the average landowner during July and August. So you get the general trend of the direction that I'm going. I'm being a little bit facetious at this point. We got college football. Some of us even watch NFL. So, February, you've got the Super Bowl. You take those days out, we've got 3 days left in the burn window. So you get the general idea of what I'm trying to convey here is that it's easy to find lots of reasons not to burn. So we need to be looking for reasons to burn because there's still so much of our landscape, even though we've made tremendous strides towards increasing the acres treated with prescribed fire each year. We need to continue to head in that right direction. So probably what you expected to hear more from me on today is how do plant communities respond to dormant and growing season fire, and how does that translate over to these two important game species that we love to pursue? Surprisingly, when you just look at understory responses within the context of wildlife habitat, we really don't have a tremendous amount of data contrasting plant community responses to growing season versus dormant season fire. But one of the best studies that's been done in that arena was by Glitzenstein and others, published in 2008. And it was actually published in a relatively small outlet, which was a symposium proceedings. But for those of you not familiar with Glitzenstein's work, he was at Tall Timbers. And this work was actually, this particular study was conducted right outside of Tallahassee. And it was in a longleaf pine savanna landscape. They collected data on these the seasonal effects of fire for 25 years, so 1980 to 2004, and that's very relevant, as you'll see in just a minute. They were also interested in contrasting plant community responses on dry sandhills to pine flatwoods with a little bit higher soil moisture, and that resulted in some interesting results as well. And all of these sites were burned on a 2-year fire return interval. This first pair of figures is probably the one that is going to be surprising to many of you. So if you look at the difference in what they refer to as lightning season or growing season fires, so these were fires conducted in May, July, and August, and they pulled across all 3 of those months to come up with those point estimates. Compared to those dormant season fires in November, January, and February, there was no statistically significant difference in the above ground understory woody biomass. So we're not seeing a huge difference in woody biomass control by burning during the growing season versus burning during the dormant season. And part of that may have had to do with them averaging across several months. And if you had confined it more so towards later in the growing season, we may have seen a different response, but we just don't really know yet. The other thing that I wanted to point out here, as I mentioned just a moment ago, that the fact that they collected 25 years of data was very relevant in this case. And in fact, it was, because if you look early on in the period, there were these tremendous oscillations in woody plant response. And so what we're learning more and more as we conduct these long-term fire seasonality and fire frequency studies is that it really takes many, many years of burning on a consistent time of year and a consistent fire frequency before we fully realize the effects of that burning regime. So moving on next to the grass response, there was a statistically significant difference here. And specifically, over time, they documented that growing season fires tended to reduce above ground biomass of grasses, whereas dormant season fire, pretty much that biomass of grasses remained consistent over time. Going on to forbs and sedges, so they combine these two functional groups of plants. They did find a slight positive, statistically significant trend of growing season fires increasing forb and sedge cover, but only in sandhill systems. So the drier sites, they got more of a positive forb response than they did on those moister flatwood sites. All right, so the next question obviously is, how do these results align with deer and turkey habitat requirements? So providing a little bit of background first to kind of give you an idea of the significance of what I'm about to share related to management recommendations and how this all meshes together. We're learning increasingly that nesting cover, and in particular, brooding cover to even greater extent, is very limited for wild turkeys, especially across the eastern portion of their range. And so there's a study that is just now finishing up in South Middle Tennessee. This is conducted across a 5-county area. And they're finding that on average, single-digit percentages of the landscape are in these early successional vegetation types that are conducive to turkey nesting and turkey brood rearing. In spite of that, in this particular study, and this involved tracking of several hundred hens in their nest, nearly half of the hens chose to nest in those areas. So you get single-digit percentages of the landscape, half the hens nesting there. And of the hens that did nest there, their nest success rates were 2-fold greater. And specifically, the vegetative metric that they found that was most closely linked to nest success, and this is an actual photo of a hen nest, it was located about right here in the photo, is that the visual obstruction of vegetation at turkey height, so about from ground level to about 3 feet above the ground, and concealment cover above the nest, so they also needed some overhanging cover, were the most important predictors of whether or not that nest would be successful. So this is a landscape or a plant community type that is very limited across the landscape. We can use prescribed fire to create and maintain it. And obviously it's conveying much greater nest success. And as we'll talk about in just a second, brood survival as well. But one of the things, as I already mentioned a moment ago, that probably is the greatest barrier to burning, or one of the greatest barriers to burning for turkeys during the growing season, is this concern about direct damage of nest, right? And although that area does need additional study, there have been a couple of studies published on looking at the effects or the direct impacts of growing season fire on turkey nest. And by and large, what we often find is that turkeys generally avoid nesting in areas that are set to be burned in the current year. So once they succeed from a vegetation perspective to the state that we would typically go ahead and re-enter that stand and burn it, is probably past its prime for turkey nesting. But again, we need additional study across a variety of landscape types. So a lot of practitioners then ask when I have this conversation with them, well, how much of my property should be in quality nesting and brooding cover? And the truth is, experimentally, we've never tested that. We don't have very solid data on it. But just from personal experience on the properties that I've been on that have the highest turkey abundance, and then even going back in the literature for several decades and looking at some of the greatest turkey biologists and turkey minds of all time, it seems to be that there's this consensus around 20, 25 to 30% of a property should be in these vegetation types to support maximum turkey abundance. One thing that we definitely need to be thinking about when it comes to nesting cover for turkeys is that the proximity to brooding cover is critical. So when we're looking at that nesting cover, it's going to have much more of a taller structure to it. So maybe we're thinking about waist high to, in some cases, chest high, but we still want most of it to be open enough for the hen to be able to look around. It's comprised of more woody vegetation. But again, it also needs to be close to that brooding cover, because we've seen in several recent GPS studies that these hens are sometimes taking their broods a mile and a half, 2 miles from where they nest to where they eventually brood. Well, what do you think happens to the poults when they're traveling a mile from where they hatch at? Most of them die, right? So the closer we can locate that quality brooding cover to nesting cover, the greater the probability of poult survival. The greater probability of poult survival is probably going to be. So what does that brooding cover look like? So if we take nesting cover, which is fairly tall, maybe waist high, maybe a little bit shorter than that, so the hen can see around, compared to brooding cover, that's going to be much more woody. It's going to be much more tall and dense. So with brooding cover, we're thinking much more along the lines of what people would classically consider being quail habitat. So we want high coverage of forbs, but we want bare ground underneath, and we want space for those poults to be able to move through easily, so they're not brushing up against a bunch of dewy grass, getting their feathers wet, getting cold. They're not slowed down. They can easily just move through that landscape and forage on insects. So growing season fire in particular can be instrumental in maintaining these areas, but linking it back to the data from Glitzenstein I showed just a little while ago, by consistently being applied in order to reduce grass cover and increase forb cover. And so those are two of the main things that we're looking for when implementing growing season fire to try to maintain this particular cover type. Another thing that I oftentimes share with landowners just outside of those general fire effects is if you think about the typical fire in March, okay, and then we've got poults, running around sometime in June of the next year. Well, you're talking about, in that case, 14 months since fire. And in some places, especially with productive soils, a matter of 3 months, that 3 extra months compared to if we had burned in June of the previous year instead, can allow vegetation density and height to get to a point where that area is no longer viewed as being or desirable by that hen. So just by shortening that duration since the time of last fire, we can potentially increase the quality of brooding cover, the usability of that brooding cover to hens. So just a couple more images to kind of give you a concept of what I have in mind when I'm looking at brooding cover. So in these images, we've got some ragweed, we've got some goldenrod, and you're looking at it from above and down. So kind of the bird's eye view, if you will, and you can see that you've got that open structure, but you still have a little bit of a canopy for those poults to hide under, and they can easily move around on that bare ground and forage throughout it. Of course, we know that deer benefit from fire too. So beginning with big picture, overall, what we've seen from some of my work, I've got a couple of master students that recently finished up looking at this specifically. We found that nutritional carrying capacity overall for white-tailed deer was greatest in areas burned every 3 to 4 years. That's just overall nutritional carrying capacity. So when you start refining different types of nutritional carrying capacity during different seasons and life stages, that varies a little bit. And specifically when we're looking at times of the year or at life stages when deer require greater crude protein diets, so like around 16%, which is required to maximize antler growth during the summertime, we're going to start thinking about shifting our fire prescription to be more frequent, so increasing fire frequency. And then we might want to start rotating in some of that growing season fire once again to stimulate forbs. Of course, as I mentioned earlier, a byproduct of that is that we may decrease coverage of native warm season grasses throughout that process, but that's generally fine when it comes to considerations for managing for whitetails because they are not using native warm season grasses as a food source. Another really cool aspect of timing of fire that I hadn't thought about until my colleague, Marcus Lashley, University of Florida, shared these slides with me, is that timing of fire can also influence plant nutrition and palatability. So what we're looking at here is you've got on the y-axis the proportion of deer selected plant parts. So basically how palatable that plant is by percentage or by proportion in this case. And then going across the x-axis, we've got different months of the year. And then we've got the proportion of plants that were selected by deer within each of those months, dependent on when the stand was last burned. So the first trend that I want to draw your eye to is that in general, so we've got stands burned 1 year ago, we've got stands burned in February and then April of the current year. But in general, all three of those, they tend to decline as we go into summer. So we're getting towards the late summer stress period. That's when vegetation starts to senesce and the palatability and the nutrient content of those plants starts to decline. But of course, I'm sure the first thing that you notice, like I did when you look at this figure, is this huge spike in July. And so that resulted from this June burn that would have occurred right here between these data points, basically starting over plant growth in that area. So you've got all these plants resprouting, they're more selected, they have higher nutritional quality, and they have less structural carbohydrates in their structure. So that overall leads to an increase in that palatability and that nutrient content. So we can see a spike in selection for those plants and the nutrient availability in those plants for deer during that late summer stress period when it can be quite critical in many places in the deep south. Another aspect that they looked at in that study was the timing of fire and how that affects leaf phosphorus. So why is leaf phosphorus important? Well, we know that there's a certain concentration, and it's actually around 2,500 milligrams per kilogram of forage ingested by deer that is necessary to support a lactating doe and her fawn. And so going from the left, we can see in this first instance, in stands that had not been burned, the average leaf phosphorus concentration in that doe's diet was inadequate to support lactation. Now, going over to the next panel, February fire, we're still not above that threshold. April fire, still not above that threshold. But then once again, when we get to that June fire, we set back that vegetative growth. It's very fresh and young during that late summer stress period. And we've got diet concentrations of leaf phosphorus that are above that critical threshold for a doe that's nursing her fawn. So that's all I've got for today. If you're not aware, I co-host a podcast with Dr. Marcus Lashley at the University of Florida. It's called Wild Turkey Science, and we cover a lot of these topics in a lot greater depth than I had time to do today. And so I've included a few notes on some episodes where we discuss many of these topics and several other things and go into a lot more detail. If that's something that interests you, I also share a lot of this information on my social media pages. If you'd like to find me there or just shoot me a plain old email, that's fine too. And if we have any time for questions, I'd be happy to answer them.
We do. That was built in. And let me try kind of being a runner and bringing you a microphone. And so just kind of raise your hand or stand up and repeat.
Thank you. What are your thoughts on late growing season disrupt the sugar flow down to the roots, the help of it to resprout?
Yeah. So the question, if just in case there were some folks that couldn't hear it, was what are my thoughts on late growing season burning, in particular in reference to hardwood control, I would assume. Yeah. So the jury's still out on that. We have some limited published data on it. In fact, there was one study several years ago that was comparing triclopyr and imazapyr application and its ability to control hardwoods to late growing season fires. So particularly talking about August through October. And they did find that burning during that August through October period was about as good as triclopyr at controlling woody coverage, but that was on one study site. It wasn't, broadly replicated. So we're not exactly sure how that would be carried out else, or how that would be influenced by changing to another landscape. However, I will say that we, and by we, I mean, there's Dr. Craig Harper at the University of Tennessee that's currently leading a study that I'm participating in. And we've got study sites in Tennessee, Alabama, Mississippi, and South Carolina, 3 or 4 sites per, and we're burning spring, summer, fall, and winter. So we're including that late growing season period to see if it is better at controlling those hardwood resprouts and actually getting killed down to the roots. So data is going to be forthcoming on that here probably in the next few months. So stay tuned.
Okay, next question.
In a general sense, can you discuss the turkey population problem we have? We've got more turkeys than you could deal with 10 years ago, and you feeling good to hear a gobble or see a trap these days.
I'm afraid I don't have time to go into all of that today. That would be worthy of a much longer than a 30-minute talk or even a 2-hour talk. But I think the bottom line is that we're aware that turkeys are facing a variety of factors right now. It's not any one thing, but there have been many factors that have changed over the last couple of decades that I think that are contributing to that. And part of that is probably habitat as well. Specifically, as we're seeing such significant declines in availability of breeding cover. I mean, you guys are out in the woods almost as much as, or probably more than anybody. And that brooding cover type that I described, I mean, how often do you see that where it's not being intentionally managed for? Almost all those early successional areas are taken over by invasive pasture grasses. And we don't really have that open structure with high forb coverage and bare ground. So I wish I had time to get more in detail on that, but that's my brief answer. Yes, sir.
Yes, in your early photos, the plants for the nesting, what plant was that?
For nesting?
Yeah, that you showed.
So turkeys don't tend to be as selective for nesting cover as they do for brooding cover. And so generally speaking, you would be okay with having higher coverage of woody plants in an area that you intend to manage for nesting cover. It doesn't really matter if that's sweet gum, God forbid, he just said it, or beautyberry or muscadine vines, any of that woody cover will be okay as long as you've got some of that overhead concealment cover, but it's still low enough that a hen can stick her head up and try to, assess the situation if she hears a predator coming. Well, it's not letting me go back. I think it was coral bean or something like that. It was a vine. Yes, sir.
Yes, sir. I have 2 questions. Work at a military base, and over the last hour, we moved to probably May, must have been burning. And we've had some concern from the hunters about the turkeys, the damage might be directly to my answer was habitat improved access and turkeys and turkey. That sound right to you? I have one more question.
Yeah, so I'm generally, if I'm you're managing for multiple competing objectives, right? You're not just managing for wild turkeys. If it was as simple as that and you were just managing the property for wild turkeys, you know, my burn program would look like I'm not going to directly burn during April and May unless it's just to get acres burned that otherwise are going to go unburned for another year and I may lose my ability to burn or re-enter that stand. So I'm not going to do it on a consistent basis intentionally on a property that's managed directly for turkeys. But of the limited information that we do have from studies in landscapes similar to the one that you're managing, we have seen very few direct nest losses from burning during that time of the year. And in general, as I mentioned, but just to reiterate, it's because oftentimes hens are not selecting to nest in those areas that are slated for burning in the current year because they've become too overgrown at that point.
My other question was, talk about the grass
Mhm.
being reduced, in the growing season burn.
Right.
You mentioned up towards wiregrass.
Yes. Wiregrass is an exception.
Quick question, scales everything. If
Right.
we're focused on turkeys, would you agree in general? To say it's project 300 acres or less, and pretty much mitigate any of these theoretical impacts. If you just, if you're out there popping 3,000 acres on a block.
Yeah.
Would you agree to say 300 to 400 acres or less kind of makes all that other argument go there?
That's still pretty big scale, John. 300 to 400 acres. Right, I understand. But what we oftentimes see is very little use of the interior of those large burn blocks by hens and by turkeys in general. They tend to stay around the outside edges of those larger burn blocks. You know, if I'm managing, you know, a 600-acre tract for maximum turkey abundance, I'm probably going to try to keep my burn units down around 20, 30 acres each. But I understand what you're talking about as far as the economy of scale. And, you know, we just really don't have data to address what kind of threshold there is. Is that at 100 acres, 200 acres, 300 acres, or so on? But we do oftentimes see that very little turkey use of the interior, relatively large burn blocks.
I was going to ask you about quail. We have seen in the last year or so more wild quail than we've seen in a while.
Mm-hmm.
And this year we saw 3 coveys, different coveys in July, little thumb-sized bird. And had we burned in June, we probably would have destroyed that nesting habitat with it.
It's possible, yes.
So you don't recommend, if you pull the quail, you don't recommend burning in June, you know, yes.
Again, right. Again, so you're getting into, you know, you generally want to avoid intentionally burning on a repeated annual basis during that time of the year. What I'm talking more about is getting to acres that otherwise you wouldn't have had time to get to because of limited burn days. So I wouldn't intentionally burn during that time of the year, year after year.
Other questions? Coming to you. That mic's making its way. Is anybody going to be on deck?
So you kind of showed your slide on the June burns for deer habitat for quail and turkey. What would be the optimal times to increase habitat for say quail?
Right. So there's no one simple answer to that. And overall, my general answer when people ask about fire prescriptions for any given species is let the plants tell you when to burn. So if you understand the plant species composition and structure that you're after for the species and the life stage of that species that you're trying to accommodate, then you can look at that plant community and understand, do I need to burn this area more frequently, less frequently, or during a different time of the year based on what we know about fire effects from a frequency and season perspective. Does that help?
Other questions? Okay, great. Thank you, Dr. Gulsby.
Thank y'all.